This section is on 8.3 hyperbolas. This is the last section of the conic section, so let's go and talk about this. The equation of the hyperbolas are going to be very, very similar to the ellipse, so you have to pay attention to this. The only difference, as you can see, is going to be the minus in between the two equations. So you can see the setup is still x minus h squared all over a squared minus y minus k squared all over b squared equals 1. So again, that 1 is important for both the ellipse and also hyperbolas. And then on this one, it's going to be y minus k squared all over a squared minus x minus h squared all over b squared equals 1 right there. Okay? So similar to the ellipse, we're going to go ahead and find the center. The center is going to be then the h and the k's. Nothing has changed so far. We're still going to find the length of A. So the length of A in this case will be the square root of this. And in this case, it will be underneath the x-axis right here. So that's the distance of x. In this case, the x, or the A squared right there, if I take the square root of it, that's going to be the length for the y right there. We're also still going to look for the length of B. In this case, the B, if I take the square root, is going to be the length for the y-axis right there. And this is going to be for the x-axis right there, okay? So you'll still have the same 4 dots that you had for the ellipse, but for the ellipse, we connected the 4 dots and made actually the ellipse shape. In the hyperbolas, we're going to take those 4 dots and we're actually going to make a square shape instead. So connecting them, we're going to go square, and we're then going to draw also as the hyperbolas. Now also, the ellipse I had mentioned that usually the first part of the equation usually is the major axis, and then after that this is the minor axis. But sometimes it gets switched and it doesn't really matter. You just have to look at the denominator to determine which is the major axis. But for hyperbolas, it makes a difference because of the minus right there. There is a difference on this, so you cannot switch this. So whatever is the first variable, that is where the hyperbola is on the axis of. So in this case, since x is the variable right here, the hyperbolas will be on the x-axis. In this case right here, it's a y, so the hyperbolas will be on the y-axis instead. Okay? So let's continue on. So this is the hyperbola that we're going to create. Okay? So similar to this, I'm taking this equation. We're going to find the center. The center is the h and k's right there. We're going to go ahead and put a center dot right there. Once we can know the values of those. We're going to take the a value, so we take the square root of a. In this case, since a is underneath the y, we're going to count up on the y's, right? The same distance from the center, and then from the other way right there, from the center. We're going to do the same thing for b. We're going to find the length of b, once I know what the length of b is. Since b is underneath the x-axis right here, we're going to go to the right b, and also to the left b, okay? So then that will create the 4 dots that we did for the ellipse. But again, instead of making an ellipse, we're going to make squares. So we're going to connect the boxes and make a square. Now these are all dotted lines right there because it's actually invisible lines that are setting you up to make a nice perfect hyperbola. So with that then, we're also going to make slanted asymptotes. So slanted asymptote is from one corner to the other corner of the rectangle passing through the center right there. That's going to be your slanted asymptote. So same thing, the other side right there, make sure you get a slanted asymptote right there and also on the other side as well. Now the purpose of the slanted asymptote, as we learned back in chapter 2, was to help us guide our parabola or hyperbolas. So in this case, same thing, it's going to guide our hyperbolas, the width of the hyperbola of that. Okay? So please use those slanted asymptotes on that. Also, make sure that the parabola of this right here touches that dot right there, which is the vertex. Same thing on the bottom right there, make sure it touches and makes a touches that vertex part of it, and also uses the slanted asymptote right there. Okay? And we talked about hyperbolas. So the drawing of the hyperbola is determined by the x-axis or the y-axis that is first mentioned in the equation right there. So let's go ahead and do an example then. So example 1 I have is 4x squared minus 9y squared equals 36. And as I mentioned before, we still have to have 1 on this side right here. If you do not have a 1, you're going to have to manipulate this equation. So in this case, we have to get rid of 36. The only way we're going to get rid of 36 is if we divide both sides by 36. So it's going to look something like this now. 4x squared divided by 36 minus 9y squared over 36 equals 1, because 36 divided by 36 is 1 right there. And then I can reduce the 4 and 36. 4 goes into 36 9 times, right? And then also 9 goes into 36 4 times. So if I simplify that, we're going to get x squared over 9 minus y squared over 4 equals 1. So now this is the equation we're going to go ahead and graph, okay? So with this, we're going to do similar to what we just did on the ellipse section. We're going to find is the center. We're also going to find the A and B so we can graph this out right here, okay? So let's go ahead and graph this out. Let me pull the screen up a little bit so we can see this. Okay, so with the center right here, because the x is in the y right there, they do not have any value inside the parentheses. The center is going to become 0 and 0 right there. The a is going to be underneath the x-axis right here, so square root of 9 is going to be 3, so that's going to be the x. I'm going to just go ahead and put x-axis like I did with the ellipse section. And then same thing with the 4 right there. We're going to take the square root of 4, that's 2. And so that's underneath the y-axis, because again, the y variable is up on the top right there. Okay? So now I'm ready to graph this out. So at 0, 0 is my center, so I have a center right there. And doing the same thing as the ellipse, we're going to go 3 spaces to the left and right from the center. So I have is 1, 2, 3. And then the other direction from the center, 1, 2, 3. And then for the y-axis, we're going to go 2 spaces up and down. So from the center again, 1, 2, and then from the bottom center again, 1, 2. So again, the ellipse section, what we did with the 4 dots, we just connected it, made a nice ellipse shape. But in this case on the hyperbolas, we're not making an ellipse. We're actually going to go ahead and make squares with dotted lines. So make sure it's dotted lines. So using a straight edge, you're going to go ahead and make dotted lines. And it's going to connect the 4 dots that you created. So something like this. Okay? And then we're going to go ahead and do the slanted asymptote. Make sure it passes through the center when you do your slanted asymptote. So again, that's dotted as well, because these are all imaginary lines to help you set up for the nice perfect hyperbola that you're going to create. So we're going to go through the center, and from corner to corner using a straight edge, something like that. And then from there, again, look at the first part of the equation. If the equation says x variable, that means the hyperbolas will be on the x-axis. So this right here is the vertex of that one side of the parabola, and we're going to use this dotted line right here to give me the width of that. So I'm going to go ahead and use it as my width right here for the parabola, and use it as my width right here. And doing the same thing, we're going to take this as my vertex. I'm going to use this as my width right there, and then we're going to use this as my width. So when you do this correctly, all of this dotted stuff should be lightly done. Do not erase it. Just leave it as it is. Just make it light. And then darken is the hyperbola piece that you need right there. Okay? So now let's do another example. Example number 2. So example number 2 says we have this 9y minus 1 squared. And we have this minus 25 parentheses x plus 2 squared, and then equals 225. So same thing, I want to have a 1 on this side right here, so we're going to divide both sides by 225. So we have then is 9 parentheses y minus 1 squared over 225 minus, and then 25 x plus 2 squared all over 225 equals 1. And we should be able to simplify this right here as well. So 9 should go into 225 25 times. And then 25 should go into 225 9 times. So if we simplify that, we have is now y minus 1 squared all over 25 minus x plus 2 squared all over 9 equals 1. So again, this is going to be the equation that we're going to graph out for the hyperbola right there. Okay? So we're going to still find the center and the a and b. So let me go ahead and do that. So we'll erase all of this right here. Okay, so again, same thing. We're going to find the center. So in the center, my x number, remember, this is a plus 2, and normally it's supposed to be x minus a number. So in this case, it's supposed to be a negative 2 for the x value. Y is going to be positive 1. And then my a is going to be underneath the y-axis right here. So it's going to be square root of 25, which is 5. So that's my y-axis. And my b is going to be underneath the x, so square root of 9 is 3, so that's my x-axis. And now I'm ready to graph it out. So at the center of negative 2, 1, so here's 1, 2, 1, so here's my center right there. We're going to go ahead and go 5 on the y's. So from the center again, 5, so that's 1, 2, 3, 4, 5. and then go down 1, 2, 3, 4, 5, and then we're going to go 3 to the x's. So that's 1, 2, 3 right there, and then 1, 2, 3 right there, and we're going to create our boxes right there, or a square with the dotted lines. Okay, something like that. And then we're going to have a slant asymptote. Remember, it starts from one corner to the other corner, passing through the center. So I'm going to cheat a little bit and start from the center out. So that way, since I don't have a straight edge with me. So we're going to go that way instead. And then do the same thing for this one. We're going to go from center to the corner. And from the center to the corner. Okay, something like that. And then we're going to look for is where is the hyperbola. So looking at the equation, the first part of the equation variable is a y right there. So that means the hyperbola is on the y-axis. So then using this as the vertex of the parabola, we're going to go ahead and use the width of the asymptote right there. Use the width of the asymptote. And then same thing right here. We're going to use as the vertex. Use the width. And then also use the width right there. So that's going to be the hyperbola right there. Okay? That's it. So go back now and look at your notes, and we're going to be able to do this for classwork now.